Okay, our topic is steel. So steel is a man-made metal derived from iron, which is the major constituent. Remaining components are small amounts of other elements. It is added to improve the quality of steel. So the basic uses of steel is for fabrication of beams, girders, columns, struts, ties, section plates, and bars. So how do we manufacture steel? Steel making is the process for producing steel from an ore and a scrap. So first stage is preparing the mineral of iron. So it starts in the mine or quarry where it is obtained. Its nature in a rock within iron, oxide, dirt, and other impurities. As per our other lectures regarding the stone, no. So if you quarry the mineral of iron, no, you will encounter other impurities in that stone. So you need to remove those impurities. Okay, so the process is to grind it into sizes that and separate the iron core the iron ore that is attracted to magnet and the the part of the rock that is not attracted to the magnet, as you can see in the figure. No? So the second process of preparing the mineral of iron is the mineral is washed to remove the dirt, and then it is crushed into fine sand. No? And after that, it is sieved. No? It is sieved and then again separated from the ore. So there is a process that you need to achieve a certain size of sand, no, for this particular type of manufacturing of steel. So after that, it is now put into a blast furnace, no. So it is mixed with the limestone, coke, and the ore, which is what we processed before, no. So the coke is the fuel, which few impurities and high carbon content, usually made from coal. Then limestone, a sedimentary rock consisting predominantly of calcium carbonate, and the other product is the iron or the ore. Okay. After that, no, this is the figure. No, this is how it is put into a blast furnace. No, so the temperature is very high, about 1,500 degrees centigrade. So it's the melting point of steel. No, 1,500 degrees centigrade. So the iron ore, the coke, and the limestone are poured on top, and then it is burned. No, okay. So up to 1,800 degrees centigrade, and there is what you call a molten slag on top and the molten iron at the bottom. And the molten iron is being collected, no, by a drip mold, and the molten slag is being collected for the slag. Okay, so as you can see, there is the molten slag is the one on top of the molten iron. So the molten iron, no, is called this is the lower part of the blast called the crucible. The lower part of the blast furnace is called the crucible. The melted mineral precipitated on it is the pig iron or the molten iron. So this is the pig iron. After it's molten, it's called the pig iron. So the pig iron is the usable part of this process, no? The pig iron. Okay, so the pig iron usually cool in the mold, no? So it is shaped like that, and they are transported to steel companies. So this is the pig iron contains too much carbon and impurities in the composition. They need to reduce the carbon before becoming to steel, no? They need to reduce contents of carbon. The third stage is this when the carbon are reduced, no, inside a converter. Okay, and then scrap is added to the pig iron so that the scrap is recycled. Oxygen is injected in order to burn the carbon and eliminate the impurities. After the slag is removed, so that the slag and the liquid steel is ready to get its final shape. So the liquid steel, there is other minerals are added to the liquid steel, like manganese to strengthen the steel. You add chrome to create a steel chrome, nickel, phosphorus, and this can create different properties of the alloy. Adding carbon increases the tensile strength. If you add more carbon from the processed ore, it strengthens and hardens but lower the ductility and toughness. In building, we use structural steel which has a low carbon up to 0.1% to have conductivity and yield. So this is the process in making what you call steel section. Okay, so this is the process we talk about, and then this is the pig iron. Then it is molded into different shapes, after introducing other minerals. So we have different types of product of steel. We have the cast iron, the rough iron, and the steel. Okay, so the cast iron, it is crude, containing 2 to 4% carbon. The melting point is about 1,200 degrees Celsius. It is hard, and the compressive strength is 6.3 to 7.1 tons. The ultimate tensile strength is 1.26 to 1.57 tons. The rough iron, this is the purest. It contains up to 0.25% carbon. The melting point is 15 degrees Celsius. It cannot be hardened. It cannot be hardened or tempered, And compressive strength is 2.0 tons to 3.15 ang kanyang tensile strength. Okay, so the compressive is lower, but the tensile strength is higher. In the compared to cast iron, the steel, it is midway from rough iron to cast iron. So the melting point is 13,000 to 14,000 degrees Celsius. It can be hardened, it can be tempered. The compressive strength is 4.75 to 25 tons. The compressive is higher than the cast iron, and the tensile strength is higher than the rough iron, which is 5.51 to 11.2 tons per square meter. So the steel is the most commonly used type of byproduct of the ore. The cast iron, it does not rust easily, so that is why they are used for pipes, and other. Okay, so the cast iron, it doesn't absorb shock, and the rough iron, it cannot stand heavy shock, and the steel can absorb shocks. The cast iron is brittle and cannot be welded. So this is one thing that you should remember. The cast iron is brittle and cannot be welded or rolled into sheets. And the rough iron is easily forged or welded, and the steel is rapidly forged or welded. So the rough iron and the steel is the one that can be welded. Okay, but the cast iron, you cannot weld the cast iron. So the cast iron, what is the usage? What are the products of cast iron? It is used for water pipes, sewer drain pipes. It is used for making machine parts. It is used for lampposts, columns, and railings. Some of the cast irons are used for because the cast iron is very it's a material that you can what you call this, you cannot weld, so you only use bolts and nuts for this type of metal or steel. The rough iron is costlier than the mild steel, so being replaced by the latter, it withstands shock without permanent injury. So it is used for chains, crane hooks, railways, and railway couplings. The steel is the main use. That is the type of product that we commonly use, the engineers and architects. It is used for reinforcement, for reinforced concrete construction. It is used for making steel members like bolts, rivets, and sheets, or plain corrugated sheets. It is also used for making cutlery, files, machine tools. Okay, so So steel versus cast iron. So up to 1.5% of carbon combines with iron, and more than 1.5 to 4.5% present as free graphite, known as the cast iron. So the steel, no, it's only about 1.5% carbon, no. The increasing the carbon content produces increase in shear strength and hardness, no. If you decrease the carbon content, it decreases ductility and but you decreases ductility and hardness if you increase the carbon content. Okay, so we have different types of steel: the dead mild steel and the mild steel, the medium carbon steel, the high carbon steel, and the cast steel. So the dead mild is 0.15 less carbon. The mild steel is about 0.15 to 0.30 carbon. The medium carbon is 0.30 to 0.80 carbon, and the high carbon is about 0.80 to 1.5% carbon. So the cast steel or the tool steel is more than 1.5% carbon. Okay, so the dead mild steel, has carbon content varying from 0.15 to 0.3%, and it is used for making various components like sheets, strips, wires, and rods. The mild steel, it is tough and more elastic than cast iron and rough iron. It is ductile, malleable. It is more prone to rusting than rough iron. No, it corrodes quickly. It is easily forged, welded, and riveted. No, it withstands shock and impact as well. Not as much affected by salin water. Is equally strong in tension, compression, and shear. Difficult to harden and temper. Then we also have the mild steel uses. No, it is used for I section, T section, channel, angle irons, round bars, flat bars, plates, tubes, no, plain and corrugated metal sheets. So majority of our material that's being used for construction is mild steel. So we have also medium carbon steel. No, it is granular, more tough than mild steel, and elastic. Easier to harden or temper, more difficult to forge and to weld, stronger in compression than in tension and shear, withstands shock and vibration better. The medium carbon steel uses is for making deals, files, and chisel. It is used for making those parts that are hard, no, tough and durable and capable of withstanding shock and vibration. So this carbon steel, the medium carbon steel, are using for our drill bit. No, it is used for making hammers. It is used for making materials that need to be hard, no, and tough. So high carbon steel, increased tensile strength leads to less weight of being used as the mid compared to mild steel. Structure becomes lighter, resists corrosion better, tougher and more elastic, more brittle and less ductile than mild steel. So high carbon steel is more brittle, no, than the mild steel. So the high carbon steel uses, it is using for reinforcing pre-stressed concrete structure. So the steel, types of steel according to the elements used, steels that owe their properties due to carbon are called carbon steel. And steel with properties due to elements that other than carbon are termed as alloy steel. Okay? Carbon and alloy steel. Alloy is from other elements, no, other than carbon, and for majority of the element is carbon, that's called carbon steel. So alloy steel, the element that impart distinctive characteristics to steel, are added to iron to produce an alloy steel named after the element added. So prepare to increase strength, hardness, toughness, resistance to corrosion, and thermal and electrical conductivities. So we have two types of alloys. We have the ferrous alloy and non-ferrous alloys. The ferrous alloys, you add chromium, nickel, vanadium, tungsten, molybdenum, manganese. Those are the the elements that you add to steel to create a ferrous alloy. So these are the different types of structural section. We have the hot rolled section. Hot rolled means that from the melted steel, you create a section, a rolled section. So it comes from a melted steel. The cold form section, it is from a flat sheet, no? flat sheet of steel. No, the thickness may differ from a thin sheet to a thick sheet, but it is made from flat steel. It is bended to create those specific shapes. No, so that is the main difference between hot rolled and cold form. Okay, so different types of hot rolled. We have the I section, the H section, the I section, the tapered flange, parallel flange, the equal angle, unequal angle, the T-cut form, the flat, square, and round. In cold form, we have also the equal angle, unequal angle, and the the lip angle. So lip angle, so this is the one that it is only from cold form. The channel, we also have that almost the same as the parallel flange. The lip channel, so this is unique for the cold form. The lip Z, we have also circular, square, and rectangular. So that is the cold form section. So usually the section that is what you call solid, these are hot rolled. Okay, so the hollow sections, which is usually you see here, that is all the circular, square, and rectangular. Those are cold form. So tolerances in structural steel. So it is not possible in rolling process to produce a section to the exact dimension. So there is what you call tolerances. No, you cannot produce an exact dimension from one end to the other end. Slight variation in members' lengths or inaccurate location of holes in the metals. No, out of squareness of the members. If you order a square or tubular bars, no, sometimes the squareness differs from one end to the other end. Variation of depth of welded girders, other dimensional variation. So this is the what you call the tolerances from steel structure or structural steel members. The most common method in joining structural is bolting. No? So if you have a non-weldable metal, you use bolts, no, for joining metals or steel. No, so you use bolts. So there are different types of methods how to bolt a two metal sheets or two metal sections. No. And another one is welding. No, there are three types of welds. We have the butt weld. No, as you can see in the figure, the butt weld. We also have the fillet. No, in joining two sections. No, that is full penetration butt weld. Full penetration butt weld. That is and also the lap weld. No, and the fillet weld. So the different steel section, we have the I section, T section, channel section, angle section, steel bars, tubes, plates, sheets, and strip. We have also the Philippine National Standard, the PNS 49-2002. This is the specification for steel bars for concrete reinforcement. The scope and application, this standard specifies the requirement for deformed steel bars for concrete reinforcement. It applies to steel bars manufactured from prime billets or ingots supplied as rolled or hot rolled with subsequent quenching and self-tempering. 6 grades of steel bars are defined, namely grade 230, 275, 415, 230W, 275W, and 415W. The W grade steel requires a maximum carbon content or carbon equivalent of 0.55 and a maximum carbon of 0.30%. So W means that you can weld those types of steel. Okay, so as you can see in the table, no, regular steel bars, we have the 230, 275, 415 grade. And we have the weldable steel bars 230W, 275W, and 415W. So those are the weldable bars, no? Because you have different types of way to attach two bars or two plates or two sheets, no? Two metal sheets. So you need to know if you will attach it by welding or you will attach it by bolt, okay? Or both welding and bolt. If you will attach it by welding, you need to buy a weldable steel bar, okay? So we also have the different types of, these are the characteristic, the mechanical properties. We have the yield strength, tensile strength, the elongation percent, handling angle degree, and diameter of pin or the nominal diameter of the specimen. So these are the technical mechanical properties. These usually the properties that are shown in the table are commonly used by engineers in calculating the type of or the specification for the steel that they will use for their structures, the computation of the structure. This is the nominal dimension and unit mass. This shows the diameter of the rebar and the weight of the rebar per meter, kilogram per meter. So as you can see, if you have a 10 millimeter, the unit mass per meter, kilogram per meter is 0.617 kilogram per meter of a 10 millimeter rebar. If you have a 32 millimeter rebar, a 1 meter 32 millimeter rebar, the weight is about 6.3 kilos for a 1 meter na 32 kilograms, 32 millimeter. So this is the stable. This table is very useful in calculating the weight of the building and the weight of the steel that you will procure. Okay, now today the cost of the steel per kilogram is about, it ranges about from 40 pesos to 60 pesos per kilo. That is the cost per kilo of steel. Okay, so there is also what you call tolerances, as I have said before. No, if you buy a 6 meter length bar or a rod or a tube, there is a tolerances of plus minus 40 millimeter. It means that it may be 40 millimeter longer or it may be 40 millimeter shorter. So that is the tolerances for every 6 meter length of steel. Okay. So the markings for the steel, we have the manufacturer's mark. That is the manufacturer's mark. We have the grade, which is shown in I. We have the bar size, which is 32. No? And we have the weldable. If it's weldable, you can see the W. So this is the markings of a rebar. So if you buy a rebar, you can see those markings at the end of the reinforcing bars. There is also what you call a dash, no, for the rebar, no, and a grade, color grade, no, for the reinforcing bars, no. The dash or the grade may differ if it is a angular or a reinforcing bars, no. It may differ, no. So the angular bar slash or the dash may be different for a angular or a reinforcing bars or a corrugate, what you call this, deform bars. No? We call this deform bars. So this is also similar to the table I've shown before, but this one, it has the nominal length or standard length of rebars. No? We can buy rebars 6 meters, 7.5, 9 meters, 10.5, 12 meters, 13.5, and 15 meters bars or reinforcing bars or deform bars. No, so the maximum length of bars is about 15 meters. No, so the minimum length is about 6 meters. Okay, so if you will create a cutting list for rebars or deform bars for a beam, you need to make sure you need to identify what length of rebars you will buy so that there will be less waste in your cutting for rebars. Okay, so that is one rule. No, you need to know that if the beam is about 8 meters, so you can buy a 9 meter length rebar so that the 0.5 will be bended on the other side and the 0.5 will be bended on the other side. But if there is what you call a L over 4, you need to make sure that you will buy, maybe you can buy a 2 rebars. No, you can buy a 6, a 7, a 6 and a 7.5. No, or a maybe you can buy a 10, 15 meter and cut it into two. No? So it will depend on the cutting sequence, the cutting list that you will arrive, no, for the beams, or maybe for the columns, no, in case you will create a cutting list for the columns. So the deformed bars, or the deformation of the deformed bars, there is what you call a deformation. No? So these are the standard, no, spacing of the lugs. No? These are the lugs for the deformed bars. No? As you can see, there is the in millimeter, so 7 millimeter for the 10 millimeter diameter. If it's 12 millimeter, the distance of the lugs is about 8.5. No? Okay, so this is a standard, no, table for checking the deliveries of your deformed bars. No? This is very useful. This table is very useful if you are working as a quality control architect or quality control engineer. Okay, so we have different common steel members like the T-bar, no, the tapered T-bar, the angled, the cold form tubular. This is the wide flange, the I-beam, and the channel. Channel is a tapered seal. No? So the ASTM is formerly known as American Society for Testing and Material. It is an international standard organization that develops and publishes voluntarily consensus technical standards for a wide range of material, product, system, and services. So you can see that ASTM is used for as a standard for the different types of sections of steel tubes. It can be a round, square steel tube or rectangular steel tube, depending on the use. We also have the roofing. No, steels are also used to make roofing. These are the different types of roofing. We can create a rib type. These are corrugated, and this is the tile roof. No, and also steel can also use for decking. No, the decking, you will pour concrete on top of this decking. No, you will not use a formwork, but instead use a steel decking, and you will not remove the decking afterwards. No? So after you poured concrete and the concrete is cured, no, for the slab, you will not remove the steel or the steel deck. That will be part of the structural reinforcement of the slab. So the beam sizes, these are the different sizes of beams available in the market. Okay, so and these are the markings for angle bars. No, usually we can see the company logo. This is the company logo where you bought the angle bars, and we have the logo, the leg length, no, the leg length, and we have the grade. No, this is the grade of the markings. No, so these are the different grade markings. As you can see, 250, 185, 235, 275, 355. No, these are the grade markings that you will see on angular bars. No. So these are the different color coding at the end of an angular bar, no? Blue, red, yellow, and this is the thickness for that particular code, no, or color. Okay, so as you can see, the silver, it's a 12 millimeter thick rebar. So this is very important in stacking, no, or storing reinforcing bars. You can easily see what is the size of the rebars, no, or the thickness of the even in reinforcing bars, deformed bars, there is also color coding. Okay, what are the steel structures? In steel structures, structural steel is the main load carrying material to transfer the load within within them and to transfer load to the ground. So example of steel structures, we have the I-beam, the sections, the channel, steel plate. Steel concrete composite structure are also used in high-rise buildings. So sometimes we use a composite structure, a combination of steel and concrete. Those are called composite structures. So properties of a structural steel frame. So it can withstand a long span. No, if you use a steel frame, the support, no, can be much wider than the concrete. Column with columns on small sections, great building heights and high load bearing capacity, combined with low dead weight of the structure. It is structural system in which openings can be easily provided, and to simplify installation and services. Okay. So another property of steel frame, no, the construction time is shorter, no, because of the um, what you call prefabricated components, and it has close dimensional tolerances, is in fixing and cladding because of the because it's you can easily put or install anything on steel, no. Erection independent on weather condition, because this is faster and you can schedule your erection of members, no, because you don't need curing time after you erected the steel. It attains its strength, no. The modest demand of space on site, you don't need to store cement, concrete, sand, no, on the site, because you need only steel, no, and it uses dry construction, no? So you need to use water for this type of construction, the steel frame. So it has greater flexibility, limited number of internal supports because of the long span, adaptability to of frameworks to change of use, increasing effective life of the building, because steel has a longer lifespan than concrete. Is in dismantling or demolition. Common steel structure, we have the roof truss in factories, cinema halls, railways, crane girders, columns, beams, plate girders, bridges, transmission towers, water tank, chimney, and others. So these are sample of steel members, no, interconnected to create a frame, no. So this is a I section. So this is called also a drawing of a concrete, steel and concrete slab. This is the floor slab. You have supports that are all made of steel. So this is also a picture of a cold form steel used for ceiling and used for wall. And these are steel members that you can use for to strengthen this cold form steel construction. So it also used for towers, no, for communication tower, electrical towers. It was also used for old arch bridges, for frame buildings. Okay, you can see the frame buildings here. Okay. Industrial buildings for factories, warehouses. No, this is the interior of the structural industrial building. It is also used for truss bridges. Okay, so during the early 1900s, there are a lot of steel truss bridges all over the Philippines, no, even on provinces, no. You can see the truss bridges that are made of steel, but nowadays they replace it with reinforced concrete bridges. Suspension bridges. Okay, this is another suspension bridges. It looks like the Golden Gate Bridge. I don't know if it's Golden Gate Bridge. I don't think it's Golden Gate Bridge. No? This is a cable stayed bridge. Okay, it is using cable. No? Also is a material made of steel. Okay.